Here's problem 11-59 for your integrated 3. It says expand these binomials, a plus b to the fourth. So this is letter A. So I'm going to use my Pascal's triangle. This thing, I could multiply it out like this. And do a lot of multiplication. Like, you know, I could FOIL them out or whatever, or make some billion multiplication boxes, but we found out that you can use a shortcut, which is Pascal's triangle. So since I'm only going to the fourth power, I'm just going to draw Pascal's triangle. You start with a 1, and then you put 1s on the side, and then 1 plus 1 is 2, 1 plus 2 is 3. So I just draw one of these on my paper, like I just made this just to do this problem with. And then I see that there's a 4 here, so I need to go to the fourth row, the one that starts with a 4. They call this the 0 row, first row, second row, third row, fourth row. These right here are going to be my coefficients of my terms. I'm going to end up with 1, 2, 3, 4, 5 terms. And I feel like I probably don't have, I think I have enough room. I'll go ahead and put these in. So these are the coefficients. It's going to be 1 times something, there's going to be A's and B's in there, and then 4 times something that has A's and B's in it, and then 6, and then 4, and then 1. So the A's are going to go in descending order. So this is going to be A to the fourth, A cubed, A squared, A to the 1, A to the 0, and the B's are going to go in ascending order. B to the 0, squared. And you'll notice that the exponents, they always add to 4. See, like 4 plus 0 is 4, 3 plus 1 is 4, 2 plus 2 is 4, 1 plus 3 is 4. Okay, and then all I have to do, so that's just a pattern. When you're squaring out a binomial or raising it to any power, third, fourth, fifth power, however many power, whatever exponent you're raising it to, this pattern always holds true of these coefficients, and these A's and B's always hold true. The A's always go in descending order. They start with N, or whatever this is, and they go down, I say downhill. And the B's always start with 0, and they go uphill. So if I want to rewrite this all neat and tidy for my homework, I would say this is A to the fourth plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the fourth. And that would just be my answer for letter A. Now, for letter B, it's 3m minus 2 to the fourth. Okay, so so I see that it's raised to the fourth power again, so I can still use my Pascal's triangle, and I can use these coefficients. So I guess I'll just do it the same way. I'm going to have, let's see, 1, 2, 3, 4, 5 terms. 2, 3, 4, 5. You don't have to do it this way if you don't want, but that's how I do it. Okay, and actually so I'm going to go ahead and put my numbers in. 1, 4, 6, 4, 1. Now in this case, A equals 3m, and B equals negative 2. So I think I'll just write little parentheses for them. So remember, this was A to the fourth, B to the 0. So this will be okay, let's make sure I do it right. The first parentheses is where I'm going to put A's. So it's 4, 3, 2, 1, 0. And then the second one's where I'm going to put the B's. So 0, 1, 2, 3, 4. And I can check myself because they have to always add up to 4, like 3 and 1. And then I'm going to stick the A's in here. I said A was 3M. Barely have enough room to do this. And then B we said was -2. Okay, some of you might be able to do some of this in your head and you didn't need to do all the parentheses. So then I'm just going to go through each of my 5 terms and try to clean them up. Now I see that -2 to the 0 power, anything to the 0 power is 1. So that's just going to go away. And then 3 to the 4th power, can I do that in my mind? 3 times 3 is 9, times 3 is 27, times 3 is 81. I've got 81 m to the 4th for my first term, I think. And then 3 times, so 3 to the 3rd, I'm going to do this in phases, I think. I'm going to say 4 times, and then 3 to the 3rd, 3 times 3 is 9, times 3 is 27, m cubed. And then -2 to the 1 is -2. I'll go back and clean this up a little bit later, but I see it's getting a little hairy here. So I got 6, and then 3 squared is 9. And then -2 squared is 4. And then what's -2 cubed? Is that -8? And then anything to the 0 power is 1. And -2 to the 4th would be 2 times 2 is 4 times 2 is 8 times 2 is, would be 16, I think. And so this one's all done. And this one's all done, but I can clean these up a little more. So let's take the -2. Oh, let's get a calculator. Let's take the -2 times the 4. That gives me -8. And -8 times 27. That would be -216. So I've got 81 m to the 4. I should have wrote a minus sign. Okay, 6 times 4 is 24 times 9. That's 216 again. And then 8 times 3 is 24 times 3, 72. I should have written that as a minus. So let's check our answer. Oops, I made a mistake on the 90. I should have got 96 right here. So we'll check that one out. Everything else looks fine. So why did they say this is a 96 right here? They're either wrong or I'm wrong. So let's see. 1, 4, 6, 4, 1. So the 4 is right. 3m. Oh. Oh. Okay, so 4 times 3 is 12, times 8 is 96. Sorry. Huh. Oh, I think I said 8 times 4 was 24 or something. So anyway, you can use your calculator. Just I multiplied these 3 together wrong, but we got it now. So your final answer should look a little bit like this. And there you go.